good evening and welcome to today's episode of our lecture. Today we are going to continue with our Chem 101, and our topic today is just on a periodic table. We are going to look at the periodic table. In chemistry, what is the periodic table? The periodic table is just a table showing arrangement of elements. Some of these elements are dated as far as prehistoric, and some are discovered by scientists along the line. But however, it is not just discovering the element that matters, but what matters most is to arrange these elements in accordance to their chemical and physical properties. This has been achieved by people like Dmitry Mendeleev, a Russian, and Lothar Meyer, a German. Dmitry Mendeleev, out of their own wisdom, were able to propose a law, and that law is known as the periodic law. The law states that the periodic property of an element is the periodic function of the atomic number. The atomic number. So the atomic number has a very big role to play. It determines the position of that element in the periodic table. Now the periodic table is made up of 18 groups. The vertical column from north to south, the vertical column is known as the group. The vertical column, vertical from north to south, is known as the group, and the horizontal column from the west to east is known as the period. It's known as the period. In fact, the periodic table is made up of about 18 groups altogether. We have the first 8 groups of the representative element. We have another 10 groups for the transition elements. The first group is known as group 1. It is 1A, 2A, 3A, 4A, 5A, 6A, 7A, and 8A. And we have the transition elements too, which are 1B up to 10B, that is from the scandium to zinc. In the case of group 1, we have our hydrogen down to lithium, sodium, and one thing that is so common among these elements here is that they have one electron at their outermost shell, and that one electron determines the chemistry of members of this group. Group 2 have 2 electrons at their outermost shell. Group 3 has 3 electrons. Group 4 has 4 electrons at the outermost shell. Group 5 have 5 electrons. Group 6 have 6 electrons at the outermost shell. Group 7 have 7 electrons at the outermost shell. And Group 8 have a complete electron at the outermost shell. That is, they have an octet configuration. You call it an octet configuration. Cover. Octet. Octet is 8. Now, there's a law, and that is the periodic law. The periodic law states that the properties of elements is the periodic function of the atomic number, so that the atomic number determines the properties of each of these elements, the properties of each of these elements. At the same time, after this representative element, where we have group 1, group 2, group 3, group 4, group 5, we have the transition. The transition is in between this and this. The left side, group 1, group 2, up to group 3 are referred to as the metals. They are all metals. They are all metals except hydrogen that is in that group by virtue of the outer electron that is just 1, but it is not a metal anyway. Group 1, group 2, they are all metal. Group 3 are metal. Group 4 are referred to as metalloids. Group 5 are non-metal. Group 6 are non-metals. Group 7 non-metals, and group 8 are gases. They are all gases. That is from helium down to argon, neon, radon. They are all gases. We have another group here. You call it another period here. This period, you call it the lanthanide. The lanthanide period, the lanthanide. You call them lanthanides. And we have also the actinide. The actinide. The transition element, they are referred to as the D block element. The D block elements while the lanthanides and the actinide are referred to as the F block elements. The representative elements are referred to the S and P block elements. They are referred to as the S and P block elements. Tentatively, this is just the picture of the periodic table, and just going through the periodic table, it can speak volumes as per the chemistry of element. The position will tell you a lot about it. When you look at this, they're all metals, and as you look at it, as you move down the group, the sizes of this atom, the atomic radius, increases down the group. In each of this group, lithium, sodium is bigger than lithium, potassium is bigger than sodium, down. It moved from lithium down to cesium and fractium. So also are the gases and in other group. So the chemistry of the transition element, the chemistry of the F block are quite different from the chemistry of the S and P block elements. So in our subsequent lecture, we'll take each of this group and look at how we arrive at arranging these elements into their respective group. We arrive at placing these elements in their respective group through what is known as writing out their electronic configuration. That is writing out their electronic configuration. And we said the outer electron, except in one or two cases, determine the position of that element in the periodic table. At the same time, don't forget the pioneers of the periodic table are Dmitry Mendeleev, who is a Russian, and Lothar Meyer, who is a German. The other one is a Russian. The other, these are pioneers of, Dmitry is a Russian. These are pioneers of the periodic table. And I told you also that they formulated what is known as the periodic law, which states that the properties of element is the periodic function of their atomic number, which tentatively means the behavior, the character of this element revolve around their atomic number. Thank you for listening, and by the special grace of God, in our next lecture, we'll be able to write the electronic configuration of some of these elements and why they occupy and the position they are supposed to occupy in the periodic table. Thank you.